This is Dan York, and I'm here at the 86th meeting of the Internet Engineering Task Force in Orlando, Florida, with Chris Griffith from Comcast, and we're here at the Bits and Bytes networking tutorial. And so, Chris, you want to maybe tell us a little bit of what you do at Comcast?
Sure. I'm the Director of High-Speed Internet Engineering at Comcast. I manage all the high-speed internet services as well as new businesses at Comcast.
Great. So you've got a demo that we're going to take a look at here that talks about Bufferbloat. So first of all, before we get to the demo, could you explain simply what is Bufferbloat?
Absolutely. So Bufferbloat was actually discovered by a group of open source developers, including Jim Geddes, Dave Täht, and a number of other folks. It's a problem with buffering associated to the amount of buffers and the size of buffers associated with traffic through the network. So it's technology now that we're leveraging, and there's a few variations of it that allow for smaller or dynamic buffers to help push traffic more efficiently through the network. And it's something that we're looking to potentially roll out into our network to help facilitate better services for our customers.
Okay, so to translate that for the non-techie user who may be watching this, because we'll have both audiences, what does this mean to the average user who's like surfing the web at home or something like that?
Sure. This actually means that you'll get better performance with the existing hardware and software that you're using today. A good example of this, and we'll actually show in the demo, both web surfing as well as if you're also using real-time communications like Skype or other types of video services, it'll allow you to get better performance out of the network and actually have a better experience with our services.
Great. So let's take a look at the demo here and see what we've got. So do you want to maybe first explain what we've got here?
Absolutely. Yes, sure. So we've actually got two setups. We actually have one that's going to have one side of the network essentially that we're going to be pushing traffic from. We're going to have a couple different things running at the same time to show kind of a real-world scenario where you might have web surfing going on, a real-time communications, video chat type thing, so we'll be using Google+. And we're also going to be running, I think, Quake server as well to kind of in the background to allow and show kind of traffic and multiple profiles running at the same time.
Okay, so what kind of network do we have here to demonstrate this all on?
Yeah, so this is actually our cable system that we've actually brought in and actually built out here on site at the IETF. So we actually have a CMTS and other component gear that with cable modems and home gateway routers that we're actually turning up, and this is what you would actually have in your home to actually use.
Okay, so we're simulating a home environment that we've got right here, and we're going to show the example.
Absolutely.
All right. Okay, so what do we do?
So I will turn over to Dave Täht. He's actually one of the folks that helped discover this issue on the network. So we're going to step through and actually kick off the process now.
Okay. Hi, I'm Dave Täht. You going to hold it for me?
Yeah.
Great. So what we have here is two modems and two routers running a firmware load called SarahWort, both configured identically. One with what's called the FQ-CODL algorithm. One without, with just the CMTS and a standard cable modem doing the buffering. Someday we hope to move this into the CMTS and the cable modem, but for now we have to test with what we got. So what we've done is we've loaded up a single TCP stream on both sides, up and down, and we've completely saturated the network. So when this happens, your web page loads slow down tremendously. Can you do me a favor and touch the mouse there?
Okay, so just to be clear, what we're going to see over here is this is the one with the fixes,
Yes.
and this is the one without.
Yes.
So we'll see this. Okay, do we want to zoom in and look at what's... all right, so are we doing this simultaneously?
Click on the run button on the left.
I'm going to click on the run button. Okay.
Your mark. Get set. Go.
Okay.
So.
All right, whoa, I can see it already over here. We've got Facebook, we've got Yahoo, Baidu, oh, and now Facebook just popped up over there. We've got Amazon showing up. We're flipping through stuff fast. And over there, we're on the second page so far. We're trying to load Yahoo's page. Wow. Okay, so we're already, what are we pumping through here? We've got lots of pages.
I'm using the Chrome web page benchmark at the same time, simulating what a user might do. And we've loaded up 10 of the top 10 websites to be able to effectively measure their time.
So we've already circulated through, and we're back into a second loop. We're lapping, and this one is way over here. Is not even, we haven't even made it through. We're at what, 4 or 5? I don't know, something. Wow. Okay, we're flipping. So this is all caused, and so again, this load on this home router, basically, or is it the cable modem? It's
Can I
Yeah.
So in this particular example, we've taken a home router running the current version of OpenWRT and the FQ Codel algorithm.
Okay.
And put it here in front of the two other devices.
So this is just a home router that's doing it. So I want one of these. Okay, so I want one because I mean, look, that's a fast load. I want that. That's wicked fast.
I think that it will be a really great short-term answer, but in the longer term, it would be much better to be fixing the cable modems and the CMTSs.
Okay. Okay. Well, that's good. This is a great demo. So let's. What else do we do?
Okay. So you don't want to see if there's any tricks? I can turn it on or off either one of these.
Sure. Show us what you want. I mean, I think this right there. I mean, I want this. Sign me up. Okay. Let's keep going. So let's do the next thing. Now we're going to look at this demo with Google Plus Hangout. So tell me what's going on here.
All right. So we have, again, the two modems connected to different devices. And one, at the moment, we have no load on the system. And our video conferencing is pretty good. There's some latency that's inherent to the system. Okay. So what we're going to do next is we're going to turn on. Again, this is simulating a person doing a single U2 upload or a big download of an ISO, just something that lasts for more than a split second. And although for purposes of the demo we have it going on for a long time, these sort of transient loads happen all the time and mess up with your voice quality, mess up your gaming in particular, and mess up DNS and web traffic, as you've already seen. So the next piece is we're going to turn it on.
Okay, so now we're going
to go from no load.
All right, so we're seeing over here. All right, so we've got a big spike in load. Okay, going on over here, which it's going to be, you can sort of see that there, that now we've gone from basically very little load on the network to coming up to being saturated again. So now we've got saturation of the network, and now we should see again, what are we going to see here? Tell me what.
What you're going to do is over here, you'll see Google's Hangouts.
Yeah.
Struggling with the voice quality, or the video quality, I should say.
Okay, so I'm over here.
Lagging ever more and more as time goes by. So you should be able, what was the Kung Fu thing? Come on, do your Kung Fu thing.
Kung Fu.
Oh yeah, look, there is a lag on there. Okay.
So that applies to almost any kind of interactive traffic.
Okay, so we're seeing again, so real-time communications is happening here. We're seeing that in under load, this one's performing better to get the signal over where that one's having that lag. So this is great stuff. So what's happening with all this material to combat buffer bloat? You know, how could people get more involved with this?
Well, we've already pushed it into the Linux 3.5 kernel. It's been out since June, since Van Jacobson and Kathy Nichols came up with the core algorithm called Codel. So it's been under test. It is deployed. It's already available in Ubuntu. People are talking about getting it in RHEL. Our biggest hope is that now that it's out there, please test it. Please break it. We would like to deploy this and make it a standard across the internet, if at all possible.
So where can people learn more on the web?
Bufferbloat.net.
Awesome. Thank you guys. This is cool. I want it in my router. Let's do it. Okay, thanks.